Good morning, I am Mr. Ish. You are joining me for this video. We're taking a break from the usual norm over here. We're looking here at some questions, random questions, which will be all pre-calculus based. So let this be a pre-calculus review and let this be sort of a test, a pre-calculus test. We'll start here with our first question, and the question is this: if pi is less than or equal to theta and that is less than or equal to 2 pi, we're basically defining this angle theta. Theta falls somewhere in between pi, which you know is 180 degrees, and 360 degrees. For what values of theta is cotan theta greater than 0? How can we do this? Well, first of all, we realize we're dealing here with a tangent style function, but here it happens to be cotangent. And then we're also looking at a certain domain. This right here is a domain. We know it's somewhere between here and somewhere here, from pi to 2 pi. So we're not even looking at this quadrant or that. We're only looking at quadrants 3 and 4. But then we have to determine this: for what values of angle theta is the cotangent greater than 0, and it's saying here greater than, there's no equal sign. So we have to look at the positive values of cotangent. You know, that eliminates very easily the fourth quadrant. Tangent is only positive and cotangent in the first and the third quadrant. So we're only looking now somewhere in the third quadrant. But we have to be very careful about this part. If we did everything here from now pi up to 3 pi over 2, because suddenly our domain has been changed by means of this question. If you do cotan of 3 pi over 2, which is cotan of 270, you're really looking at cosine 270 over sine 270, and you know what that is. That's a 0 over minus 1, and that's a 0. So automatically this angle 270 is out, because we have to be greater than. We cannot have greater than or equal to. If you do cotan of 180 degrees, which is cotan of pi, we're looking at cosine of 180 divided by sine of 180, and you know that's going to be a minus 1 over 0, and that's undefined, so obviously 180 is out. That leaves us with only a good value over here in terms of the domain, anything from pi up to 3 pi over 2, but not including either, and that right there is your answer. So for what values of theta is cotangent theta greater than 0, your answer can be expressed very well like this: pi and 3 pi over 2. Anything between this, but not including either. Hence, I'm using the circular parentheses. So this right here represents our answer, and we are done with this question. This is question number 2, and there can be no pre-calculus unless you're also looking at some sort of a binomial theorem question. We have 2a minus b. This could have been x or y, but we're using a's and b's all to the power of 7, and we have to find the fourth term. How can we proceed with a question like this? Anyhow, when we're looking at fourth term, always think of it in this way: we're looking at n minus 1, n being this right here. So you're looking at 4 minus 1, and that gives you a 3. We have a total here of 7. We're looking here in terms of combinatorial coefficients, always in terms of nr, right? Here my nr is this 7, and this happens to be my r value. R value is always n minus 1 for this style of question. So here we end up getting a 3. And then you know you're going to end up putting everything here through the formula here for binomial theorem. 7 minus 3 is a 4, and they'll come right here, and this value right here, the r, will come very well over here. All you have to do is calculate it, and then at the end we'll determine the sign. You'll do 7 factorial or 3 factorial, 4 factorial, because you know it's n factorial or r factorial, n minus r factorial. Here you'll have 2a to the power of 4, here you'll have b cubed. And then we can actually determine the sign right now. When you have a minus, it always alternates between positive, minus, and we're looking at the fourth term, first, second, third, fourth, so we'll have a minus sitting right outside. So let's actually determine all of this, and we'll post a good answer for you. In terms of this combinatorial coefficient, I get a 35. Over here I'm going to get a 16, a to the 4, and here I'll get a b cubed. What my final answer will be minus 560 a to the 4 b cubed, and that would be the fourth term of this expression expanded out, this binomial, and that answer should be good. The third question brings us to a hyperbolic question here. We're looking at this determination: hyperbolic tan x is equal to 1 over 2. We have to solve for that value of x. We break this hyperbolic tangent into its hyperbolic sine divided by hyperbolic cosine, and we can proceed with that definition. We know hyperbolic sine, e to the x minus e to the minus x over 2. I'm ignoring that over 2. Hyperbolic cosine is e to the x plus e to the minus x over 2. Those over 2's cancel out. We just are left with this, which is equal to 1 over 2. You can easily cross multiply these expressions. 2 can multiply this way and that can multiply that way. We'll be looking at 2 e to the x minus e to the minus x is equal to e to the x plus e to the minus x. What I did was multiply this way and that way. I can open this up. I have 2 e to the x minus 2 e to the minus x is equal to e to the x plus e to the minus x. Bring everything on one side and make the entire expression equal to a 0. This comes on this side and becomes e to the x. This goes on the other side. You get minus 3e to the minus x is equal to 0. Get rid of this negative exponent. We have e to the x minus 3 over e to the x is equal to 0. Common denominator e to the x. 1 goes in e to the x times it multiplies with its numerator. You get e to the 2x minus 3 is equal to 0. Take this on the other side and get rid of it. You'll have e to the 2x minus 3 is equal to 0. E to the 2x is equal to 3. 2x ln e is equal to ln 3. Natural log has been brought in to eliminate this exponent. And then 2x is equal to ln 3 and x is equal to ln 3 over 2, and this here would be your answer. But we can also express this in a good decimal answer, natural log 3 divided by 2, and we can say over here x will equal 0.549306, and this, if you plug it in places of these x's here in this expression, or if you have your scientific calculator with the hyperbolic functions in it, this answer here would be right. Question number 4 brings us to functions in terms of we're stating the domain and range of the graph that we see. We know the domain are the valid inputs, and you are always looking with regards to the domain, the left to the right extent of your curve or your function. For range, you're always looking from down to up, the lowest to the highest point. Starting here from domain, and we know we're looking here at a broken function. It's not continuous, but we can easily assess it. We're looking here our graph is coming from outside the depiction we have, so we have to assume it's coming from minus infinity. And then it comes over here at this value, we know it's minus 1 comma 0, and it stops over there, and it comes to minus 1. And there's an open value. Then it jumps up over here in terms of its continuation. Again, it's coming here from minus 1, and then it goes up to infinity. But you can see over here you have a minus 1 as an open value and minus 1 as the closed value. Essentially all of this can be just rewritten, and you can easily express it as just minus infinity to infinity, because minus 1 is relatively included in here as a part of the domain. This right here value represents the domain very well. Now for the range part, let's look at it. When we're looking at the range, we're seeing that the curve is coming here from outside the depiction we have, so we have to assume it's basically coming from minus infinity. And then it comes and it stops right over here at this value which I've written here, minus 1 comma 0. It stops at minus 1 comma 0. But then it jumps up, because there's an open value, it jumps up over here to a closed value in terms of the y. That right there happens to be a 2. So how can we express this in a good way? And I believe this right here would be that good way, because you have the range coming from minus infinity to 0, then there's this little bit of a jump, and then it goes up to 2 in terms of the range, and it stays at that range, it never goes higher. So this range determination here would be good as well. Question number 5. Find values of x in the domain 0, including 0 up to 2 pi. We have this expression listed over here. We have two different functions. When you see something like this, you want to convert everything into one expression, and it's easier to convert sine into cosine. This is the same as you looking at 1 over sine square x minus cosine x is equal to 1. Use the Pythagorean identity where sine square x plus cosine square x is equal to 1. Sine square x is equal to 1 minus cosine square x. So this becomes 1 over 1 minus cosine square x minus cosine x is equal to 1. Just do a common denominator and work only on this side. You have a common denominator here of 1 minus cosine square x. What are you going to end up getting over here? You'll get 1 minus cosine x times 1 minus cosine square x is equal to 1. But you can cross multiply this and make it equal to 1 minus cosine square x. This entire expression right here has cross multiplied with the 1 on the other side, so we can just eliminate this denominator over here. Open everything up. You'll get 1 minus cosine x plus cosine cube x is equal to 1 minus cosine square x. Bring everything onto one side of the equal sign, the ones will cancel out. You're going to be looking at, I'm going to write this from a high order exponent to a low order, cosine cube x plus cosine square x minus cosine x is equal to 0. Isolate a cosine x. Cosine x goes here, and then you have cosine square x plus cosine x minus 1 is equal to 0. You can separate this up into two parts. Let's make some space over here and we'll do all of that. In one part we have cosine x is equal to 0. That right there, and this right here represents my other part. You can't really factor this out, you have to use quadratic equation. If u is equal to, or quadratic formula, if u is equal to cosine x, then you're looking at u squared plus u minus 1. You have to send that to the quadratic formula. You'll have a minus 1 plus minus, here's my a, b and c, plus minus b squared, right? 1 minus 4 times 1 times minus 1 over 2a. You'll have a minus 1 plus minus, you'll have a 1 plus 4 root 5 over 2. All of this equaling a u. You have to get the values over here, and let's do it. In one form of the value I get a 0.618, and in the other form I get minus 1.618. These are equal to u, which are equal to cosine x. Then x must equal to the inverse of these, and let's do the inverse of these and plug some values here. 0.618 inverse cosine, I get it 51.8 degrees. We can do a little more accurate, 51.83. Then I do 1.618 minus inverse cosine. It's outside the range of the cosine function, so this gets out. We only end up having two values, 51.83 and this. X is equal to inverse cosine of 0, which will be pi over 2, which is 90 degrees, and 3 pi over 2, which is 270 degrees. But the normal cosine function has a period of 360. So if you add 360 to this, you're going to be outside the domain. So this value will have to stand as it is, and this value will stand here as well. So we are getting three values here. One is 90, one is 270, one is 51.83. But technically you have to check your answers by plugging each of these in places of x's and see if the answer is indeed true. And we'll do that one by one and we'll check which one works. If you do 90 in terms of, it's a 1. You'll do 1 minus 0 is a 1, so 90 works out for sure. If you do 270, you're going to get a minus 1. Sine of 270 is a minus 1. When you square it, it becomes a positive 1. When you take the reciprocal, it's still a 1. 1 minus cosine of 270 is a 0. 1 minus 0 is a 1. That's true. Now we have to actually plug in 51.83 and do some work. 51.83 sine, you square that and you reciprocal that, and you minus that 51.83 cosine value, and I get a value 0.999, and that value is good. So these three values are good and they satisfy the equation. And with that, this pre-calculus review video come to an end. You've seen the variety of questions we've seen over here. Hopefully this was a meaningful video for you all. Thank you for watching. Have a nice day.